we started our classes on differentiation and integration a while. Let me just say calculus basically. I think that was about 2 months ago or 3 months ago. I don't even know. Maybe I just check the first video and then see the time on it. So I don't even know right now. But today we'll be going into differentiation of exponential functions. Basically, I didn't want to do this video because I was thinking that when my students, because in case you don't know, we run a school, an online school, MOG School of Economics. So your students get registered. Of course, they pay to register, and we are able to link up our classes and online activities through WhatsApp. And it has been fantastic all through. So right now it is. The school is 4 months old. Yeah, it's going to be 4 months old. Later this month or next month, anyhow. But let's just come back to where we are. So my students got my attention to differentiation of exponential function and logarithmic functions actually. And I was thinking that I can't teach you everything, so why don't you just go and learn it on your own? But then I got to look into this thing and I was like, oh damn, there are some of them that are not going to get it. So let me just make videos on it, and that's why we are here today, making videos on exponential functions. We are going to be having I think 3 to 4 videos on exponential functions now, and after which we'll be having videos on logarithmic functions. So what we're talking about the differentiates, natural logs and other logarithmic functions. They are just basically simple things, and we won't delve very deep into these things because we are not mathematicians. We are just economy just borrows mathematics. So mathematics is like a tool for economists to do what they want to do. So we're just going to take the parts of all of these things that we need, in economics, and then we leave the rest for the engineering students and the students in the sciences. My name is Oluwole Godwin, and welcome back to Macroeconomics. And that is actually for someone. The introduction is for someone who hadn't seen any of our videos before, and this is your first video. And thank you very much for that actually. So you're highly welcome. Just stick around. If you enjoy this particular video, click on the like button. If you do not enjoy, click on the dislike button. It's not a bad idea, okay? And so that sends a message to us as to what to do, as to where to improve upon, and so on and so forth. And if you want more of our videos, just click on that subscribe button and notification bell. So one of our videos will pop up whenever we release them, and you'll be able to see them as quickly as possible. This is the 182nd video on the channel, so you have access to 182 videos right now: mathematical economics, econometrics classes, microeconomics classes, and macroeconomics classes. Okay, back to business. So differentiation of this. So we have given a function of x equals exponent. This is the exponent raised by g into bracket x. That is g into bracket x is a differentiable function, that is where gx, so it's like another function, so a kind of a sub function, a function inside a function. So where gx is a differentiable function. So given this, how do we differentiate this? So the first derivative, so which is f prime x rather, is going to be the function again, the original function, which is e raised by gx, then multiplied by, you differentiate the power a, which is g prime x. Okay, now that's my loop b. Let's just solve examples. So we have 2 examples on the board. We have y equals f of x, which is equal to e raised by x. Of course, you may not have y equals f of x every time, just f of x equals e raised by x, or y equals e raised by x. So how do we differentiate that? So you have y equals e raised by x. So in this case, the y dx, because we are just using y, is equal to e raised by x again, right? Then multiplied by, but you differentiate. So let me just say, let me name the power. In this case, let me name the power. No, let's just use the formula that I use. Let's just say this way, f of x. Okay, so it's going to be, so let me not confuse you. Now f prime x then will be equal to e raised by x times, where x is the gx, so and g prime multiplied by g prime x. So that is going to give us e raised by x multiplied by the time you differentiate this, you'll be having 1, which is e raised by x. So the differentiation of e raised by x is still e raised by x basically. So that's what this is telling us. Now that is for a. Then for b, we have let me use y in this case. Y equals e raised by x squared. Alright, to make this easier, I could just call this so dy dx here, dy dx, so where is going to be e raised to power x squared, the entire function again, then multiply by, this is gx, right? So it's g prime x, okay, and that's going to give us e raised to power x squared times, and we differentiate x squared, so we have 2x, and this is just going to give us 2x e raised to power x squared. Okay, so it's as simple as that. So we are done, you see. So when you're talking about exponential functions, they are just that's pretty simple. Now we can also have this. Okay, so let's say question C, where we have y equals 8e raised to power 7 minus, is it a minus or a plus? Okay, 7 plus 3x, 7 plus 3x. So by the time you want to differentiate it, so the y dx now is going to be equal to, you will write the whole thing again, which is 8e raised to power 7 plus 3x, right? Then by the time we differentiate 7 plus 3x with respect to x, so we are left with just 3. So multiply by 3. So then this is going to give us 24e raised to power 7 plus 3x. That's all. And basically in when we are doing divide the x, what we are looking for is the slope, of course. So all of this, so what we have here, for example, when we found the first derivative, this, so this is just the slope of this function. Okay, f of x is the slope. The same thing as this place, divide the x, so divide the x is basically your slope. And here as well, y equals this, doing your divide the x is basically your slope. So there are times that you might be given a value for x, and then you have to find the slope at that point. So I'm still going to be using this basically. So we have to find the slope here, where x equals to minus 4. So that's not a big deal. Just, you've already found the divide the x, we found that here. So just substitute the value of x into it. So we'll be having 24 e 7 plus 3 into bracket minus 4. Alright, which is equal to 24. This is 7. 3 times minus 4 is minus 12. Minus 12. 24e, okay, equals 24 e raised to power 7 minus 12, and that is 24 e raised to power minus 5. From the law of indices, this is basically 24 divided by e raised to power 5. So that's about that. Okay, so the value of e raised to power, let me check here. Yeah, I didn't find the value out. But if you do, let me use the calculator. E raised to power 5 on its own is so if you are making it up, I don't know the country that you have, so I just say e raised to power 5 is 148. So we have 24 divided by 148. Okay, and what will that give us? Please punch this into your calculator and let's be sure what we are doing. 0.1617. Let's just say 0.16. So the answer is approximately 0.1. So for this particular function, when x is minus 4, the slope is actually 0.16. So the slope it's a positive slope. Alright. So that's about that. Now after that, we are now going to do something interesting. And what it is that, before now we've learnt about what do you call it now, product rule. So we're going to have a question on product rule. We've learnt about quotient rule, all of those things. Those were when we began our classes on calculus. So you can just there's a playlist for that, and I'll try to include the playlist at the end of this video. But if I don't, so just type Economics on YouTube. So the page displays, and just go to the playlist section. So you have videos, playlists, description, something like that. So just go to the playlist section and go to calculus classes, I think. Yeah, calculus classes. So when you click on that, you are going to see all of the videos are arranged chronologically. So from what differentiation is all about basically, then to each of the rules. I skipped a rule though. I think chain rule, but it's not really a big deal. So if you really understand, it's not really a big deal. So I skipped that. It was unintentionally. So sorry. And so on and on like that, and you're going to guess what we are trying to say. So what we are going to do now is, let me just try to divide the board into two. You'll be having an assignment at the end of this video. Okay, so I have the assignment here. So here we have this. So y equals 2x e raised to power 4x. Alright. So here, these are two functions, so we can't just differentiate them that way, the way we've been doing what we've been doing before. So what we just do is the whole of 2x, we just name it u, and the whole of e raised to power 4x, we name that v. Okay, so v equals e raised to power 4x, and basically what we are going to use here is the product rule, and the product rule is saying that dy dx is equal to u dv dx plus v du dx. So that's about that. Okay, so dy dx now, dy dx is equal to u is 2x, right? 2x, then dv dx. So we want to so you are leaving this guy. I want to differentiate this person. So you have 2x. So you have when you have e raised to power 4x, right? Multiplied by 4. By the time we differentiate what is here. So that about that. So plus what is v? V is e raised to power. I think I can still write that here. So v is e raised to power 4x. And by the time we differentiate the u dx, so this is u equals 2x. So the u dx is going to be 2. Alright. So this is then going to give us 2x times 4 is 8x e raised to power 4x, right? Then plus 2 into bracket e raised to power 4x. Okay, which is pretty interesting. So we can just collect like terms simply. So we have 8x plus 2 into bracket e raised to power 4x. You know what is now going to happen? So we are done. This is actually the dy dx of this, but I want us to find the critical values. Okay, so how do we find the critical values? We are going to equate dy dx to 0. Okay, so to find the critical values, okay, to find the critical values, okay, dy dx equals 0. So what that simply means is that we're having an 8x plus 2 into bracket e raised to power 4x equal to 0. Okay, so basically we have 8x plus 2 equals 0, and then we have e raised to power 4x equals 0. Now let me deal with this guy first. Even if x were 0, e raised to power 4x is not going to be equal to 0. So let's assume that x were 0, for example. So we're having e raised to power 4 0, right, which is e raised to power 0, and n raised to power 0 is 1, right? So because we don't have a value of x that is going to make e raised to power 4 equals 0, we are going to neglect it. So we just neglect that, and we focus on this. So 8x plus 2 equals 0, 8x equals minus 2, and then x equals minus 1 over 4. Okay, there's some people that may not understand this jump. Okay, so we divide through by 8. By the time we divide through, okay, let me just say divided by 8, okay, x equals minus 2 over 8, and this is now minus 1 over 4. So the critical value that we are going to be using is minus 1 over 4. Okay, now the other thing that I want us to do is I want us to test if this function, okay, this one that we started with, is at minimum at this value or is at a maximum point. So what we are going to do is we are going to find the second derivative and then insert x equals minus 1 over 4 into whatever function we get by then. So if the answer were less than 0, so that means this function is maximum, okay, at x equals minus 1 over 4. That shouldn't be a big deal. We've spoken about all of this in our previous videos. And if whatever we get, that's the second derivative, if it were greater than 0, so that means the value is at a minimum point where x equals to minus 1 over 4. So let's prove that in a bit. Recall that the first derivative of this gave us 8x plus 2. Okay, so dy dx gave us 8x plus 2 into bracket e raised to power 4x. So what we have to do now is, we kind of differentiate this again. So we have the squared y, the x squared, will then be this is a product already. So if you look at what we did here, when this was 2x e raised to power 4x, we just did, it's more or less leave this, differentiate this, plus differentiate this and leave this. So that's what we did. So we left this, which is this, we differentiated this guy, which is this, plus we are differentiating this person now, which is 2, and then we are leaving this guy. So what I'm just going to do here is differentiate. Anyway, let me just say this is u and this is v. Okay? You know the formula to be u dv dx plus v du dx. So u is saying that we have 8x plus 2, which is still there. Then dv dx is telling us to differentiate this guy. So we have e raised to power 4x, right, multiplied by 4 then plus, okay, so we have v, which is e raised to power 4x now, e raised to power 4x multiplied by, when you do the u dx, so we'll be having 8, just 8. Okay, so this then is we can okay, let me say 8x plus 2, so then let me jump 4 e raised to power 4x, right, plus 8 e raised to power 4x. Alright, so I want to collect like terms kind of. First, let me multiply this by 4. Okay, when I multiply this by 4, I want to leave e raised to power 4x alone, so I'll be having 4 times 8, that's 32x plus 4, okay, into bracket e raised to power 4x, raised to power 4x, and plus 8e raised to power 4x. So here we can collect like terms. Basically, we have, let's say, AC plus DC. So this is saying a plus d, okay, close the bracket, into bracket c. So 8 times c will give you AC plus d times c will give you DC back. So that's what we're going to do here. So we take this and this. So we'll be having 32x plus 4, then plus 8, right? So everything then e raised to power 4x. So 32x plus 12 into bracket, close your bracket, because if you do not do that, let's assume you just have okay, let's assume you just did this 32 plus, so what you're trying to say is that e raised to power 4x belongs to only 12, not to the entire 32x plus 12. So let's take into brackets. So we just have this. So what we have to do now is to insert x raised to power x equals minus 1 over 4. So we have 32 into bracket minus 1 over 4 plus 12, then into bracket e raised to power 4 into bracket minus 1 over 4. Okay, so 4 here, 4 in 32 give us minus 8. So we have minus 8, then plus 12 into bracket e raised to power, this is going to give us minus 1. Okay, it is looking somehow to me already. Okay, it's looking somehow. So we'll be having, okay, 32 minus 8 plus 12. Okay, anyway, let's see. So we have minus 8 plus 12 divided by e. Okay, no problem. So 12 divided by e would give us 12 divided by e. 12 divided by e. Oh no, coming 12 divided by e. Okay, 4 points. So we'll be having, so this is minus 8, okay, plus 4.42, and this will be giving me a minus at the end of the day. Something is wrong. Something is wrong. So let's come back to this place. Let's come back to this place. 8x plus 2 e raised to power 4x. So we find the second derivative, and we have 8e raised to power 4x, and 8x plus 2 4e 4x, 8x plus 2 4e 4x. Okay, so here this is multiplied by 4. 4 times 8 is 32. 4 times 2 is 8. Yeah, so that was where the error came from. 4 times 2 is 8. So we have 32x plus 8 plus 8. Okay, 32x plus 8, then plus 8. So we have 32x plus 16. Okay, e raised to power 4x. So I think that should be the only error. So 32x plus this is 16. Okay, and this is 16. Okay, let's just try this again. So 16 divided by e. 16 divided by e. 16 divided by 5.88. 5.88. Is that what I'm meant to have? Is that what I'm meant to have? I'm meant to have a positive number. So what is going on? What is going on? 8x plus 2 into bracket e raised to power 8x plus 2, this plus this. So you have 8x plus 2 plus 4 e raised to power 4x plus 8 e raised to power 4x. So 8x plus 2. Okay, 4 times 8 is 32x. 4 times 2 is 8 e raised to power 4x plus 8 e raised to power 4x. Oh, that wasn't the way. So we have 8 e raised to power 4x 4, 8 raised to the power 4x, okay, plus 32e, okay, I think 32x plus 32x plus 8, e raised to the power 4x plus 8 again. This should actually be right. So what's wrong? 16 e raised to the power 4x, okay, then 32x minus 1 over 4, which is of course minus 8, minus 8 then plus there is another error. I'm so sorry, there's another error. What happened? This, I was trying to explain this and I just made the error myself. So we have this, okay, so let me just leave it like that. So you have 32 minus 8, so open the brackets, then plus 16 here. So they are, the two of them are the owner of e. So you have this, alright, then e raised to the power minus 1. So minus 8 plus 16 is going to give me plus 8. So a plus 8, so this is 8 into brackets, e raised to the power minus 1. Alright, and this is 8 divided by e. So 8 divided by e is going to give me 2.94. So basically, the decision rule is 2.94 is greater than 0. And whenever this is greater than 0, the function, okay, is at minimum. So the function is at minimum where x equals minus 1 over 4. Alright, the function is at minimum where x equals minus 1 over 4. So we've done, so this is actually correct. We are going to have assignments on it as I mentioned earlier. So the next thing, which is the last level we are going to do in this particular video, is to solve an exponential function using the quotient rule. Okay, so I'll get to that in a bit. The last question I'll be solving for the day, using the quotient rule, is right here on the board. Before I give the assignment out, so we have y equals the exponential is this sign or whatever, raised to the power 5x minus 1, then over e raised to the power 5x, then plus also find the y dx. Apparently, what we are going to be using here is the quotient rule. So this is u, this is v. So let's try to recall the quotient rule. Quotient rule is saying that if we want to find the first derivative of the function, so we use v the u dx. Okay, I like the way you are putting after me. U the v dx. Okay, everything divided by v squared. So since this is about u, so we just go straight into the point. So just go straight to the point. So v is this. So v is e raised to the power 5x plus 1. So what then is du dx? So du dx is we differentiate this guy. So when we do that, we have e raised to the power 5x multiplied by 5. We don't have any business with minus 1, because it doesn't have x. It's not minus 1x, so it is a constant, so it disappears. So we close this, then minus, what is u? U is e raised to the power 5x, then minus 1. Then the v dx is going to be, we differentiate this person, so we have e raised to the power 5x times 5, and 1 also disappears because it's a constant, so everything is going to be divided. It's going to be divided by v squared, and v squared is basically e raised to the power 5x plus 1 squared. Okay, so now let's just try to expand this guy. So we have e raised to the power, we have e raised to the power 5x, e raised to the power 5x, I don't want us to consume too much space, into bracket 5 e raised to the power 5x, right, minus e raised to the power 5x, so we have e raised to the power 5x minus 1, into bracket 5 e raised to the power 5x, okay, and everything is then divided by e raised to the power 5x plus 1 squared. Let's just see if we have like terms. So we have 5 e raised to the power 5x. This is e raised to the power 5x plus 1. This is minus e raised to the power 5x minus 1. So we have 5 e raised to the power 5x here, 5 e raised to the power 5x here. From here, what I'm just going to do is to collect like terms. I was trying to say earlier that if you have something like this, AD plus CD, so you can just take out the coefficient, so it will be a plus c into bracket d. This times a times d will give us ad back, then plus c times d will give us cd back. So that's what we are going to do here. So 5e raised to the power 5 is common to d, so we take the coefficients out. So here we'll be having e raised to the power 5x plus 1. I will bring the coefficient of this person here. So this one is now going to be minus e raised to the power 5x. Then minus times minus will be plus 1 here, then we close the O brackets, so we have 5e raised to power 5x. Okay, then everything will be divided by, let me just say v squared, v squared. So here we'll be having e raised to power 5x minus e raised to power 5x, so that cancels out. This takes this, plus 1 plus 1, that's 2, so we have 2 into brackets 5e raised to power 5x. Okay, everything divided by v squared, let me do it that way. So we have 10 e raised to power 5x, okay, divided by v squared, which is basically 10 e raised to power 5x divided by v squared is e raised to power 5x plus 1 squared. Alright, so that's the final answer. So this is a way to solve exponential functions using quotient rule. It's not going to be this simple every time, of course, you know, but once you just understand, once you just have this basic idea, so that's just it. I was saying that you guys have an assignment, okay? So the assignment is actually, okay, we have like a few questions. So what I'm going to do is I'm going to find the critical points of, so find the critical points of this function. So y equals 4x e raised to power 3x. We find the critical this, and then we also do for this y equals 5e, okay, raised to power minus 0.2x. So for 1 and 2, what I'm going to do is I'm going to find a critical point and then prove if the function is maximized at those critical points or not. That is, you have to find the second derivative. So the third one, then you are not looking for the critical points in the third one. Okay, let me just call this, let me say this is A. Okay, and for B, so for our question B, you just have to find the first, you have to find the, let me just say first derivative, so I won't give you too much problem. So find the first derivative of e raised to power 2x plus 1 divided by e raised to power 2x minus 1. So it's just similar to what I just solved here. So use the same method and you're going to get what you should get. So y equals this. For 1 and 2, what you have to do is to find the critical points and then show if the function is maximized or minimized at that critical point. And for B, just to find the first derivative of this using the quotient rule. So that's that about that. If you have any questions, the comments box is for you, so you can leave your comments there. And if you have anything beside, maybe you have a video request, you know, you can put them in the comment section, or a way to navigate through Econometrics YouTube channel. You can also just do whatever you want, you know, as long as it is beneficial to us and to yourself at the end of the day. Make sure you subscribe and turn on notifications. See you in the next video. Thank you.
Please like and subscribe.